Hello everyone. Today we are discussing about permutation in strings. In permutation, there are several approaches. Exploring the fundamental concepts of string permutation, delivering into various algorithmic approaches. This presentation provides a clear code-focused guide for VTech diploma learners, highlighting efficiency and best practices in Java. What is permutation? A permutation refers to the arrangement of all elements of a set into sequence or order. In the context of strings, it means generating every possible unique ordering of its characters. Why efficiency matters? Generating permutations can be computationally intensive as the number of possible arrangements grow incredibly fast with the string length. Understanding the efficiency of approaches is crucial for applications. If we take a string of four characters, there are 24 unique permutations. So for a string of six characters, this jumps to 720 permutations. As n increases even slightly, the number of permutations skyrockets, making naive approaches impractical for longer strings. This necessitates the use of optimized algorithms. Oh, let us discuss approach 1. Here we are using brute force. The brute force method typically involves iterating through all possible character placements without much optimization. While it activates the goal, its high time and space complexity makes it inefficient for anything beyond very short strings. Here is the code.
Hi, this is Thanviz, and as my friend Hemanth said about the brute force method for the permutation strings, I am here to explain about another two approaches. And the first approach, here the second approach, it is the sorting plus sliding window. It is better than brute force because its time complexity is pretty less than the before thing. Before code. Here, if you check the code, if s1 dot length is greater than s2 dot length, it will return false because it is s1 is the string. We want to check if it is present in S2 or not. If it is present in S2, its permutations are present in S2, we have to print a true or else we want to print false. Here we created a character and S1 dot to char array. It will separate the string into different characters. And here we used arrays dot sort of a. It will sort the A array and the string sorted is equal to new string. It will store in the sorted thing. And here it is int k is equal to s1 dot length. We all know k is initialized with s1 dot length. And we use it here a for loop and another character of array we use a w. And the w character also it will sort. And if the sorted or if the sorted thing like a array sort, array of a sorted and array of w sorted. So if both are equal, it will return true or else it will return false. This is the sorting the sliding window. I can say there is one more approach which is better than this sorting plus sliding window. It is optimal sliding window plus frequency. And here if we see the it will better than the why it is better than the approach 2 because its time complexity is very less and its space complexity also very less. As which as we go through into the code, if s1 dot length is greater than s2 dot length, return false. We already saw this thing in previous code. And here it is, and here we taken two arrays, int c1 and int c2. And here for we use two for loops, and one for loop is for the character c s1 dot to char array. So it will create like a b b a c a like that. And the plus plus is used to increment, we all know that. And int k is equal to s1 dot length. And in second for loop it is from the 0 to s2 dot length. And here c2 it taken same thing like as I said before, a b like that. It will increment and go. And if I is greater than k, s2 dot caret of I minus 1 slash a, small dash a, it will be minus, it will it will decrease it. So here we count the frequency, and we will check that the arrays of c1 and arrays of c2 is equal or not. If it is equal, we will print true, or else we will print false. See, as we check s1 is equal to ab, as we go through the side, there is some example input and output. As we go through it, s1 ab, and here s2 eidbao oo. Here, if we see, there is no gap between B and A. It is the permutation of AB. AB's permutations are what? AB, BA, etc. And here, if we see there is no gap between B and A, so it will print rows. If we go through the second example, here there is a gap between B and O, it is O. I mean, it is B and A, it is O. So we have to print false. And why approach 2 is better than brute force means there is no extra storage, it will controls better, and there is a cleaner logic than the brute force method. And why approach 3 is better than approach 2 because it is less overhead, it has more clear logic, and it is very interview friendly. More MNC companies are looking for the less time complexity and space complexity thing. So if we did the frequency thing, I mean, if we said about the frequency code, so we can got a more chance to select in it. So it is here the comparison table. At the most left side there is the approaches, and in the middle there are the time complexity, and at right side there is space complexity. As we check the brute force time complexity, why we didn't take the brute force, and why we didn't take the sliding window plus sorting. Why we taken the frequency plus sliding window? Because there is less time complexity and less space complexity. So here it is the comparison table. So you can know that why we are taking the frequency plus sliding window. And here the conclusion that I want to say is sliding window plus frequency is best because it has less time complexity and space complexity. Uh, and I hope you really understand. If you don't understand, recheck the video again. And I given the code which you can understand that. And this is this is what I want to say about the permutation in strings. Uh, Thank you.